Solve the following system of equations by using a matrix. In order to solve this using a matrix, and the reason why we would is because this system has three equations and three variables, and that's considered a large equation. So anytime we have a large system, that is, and anytime we have a large system of equations, we would like to solve that with a method that's designed for those, and that would be the Gauss-Jordan method. It's not that you couldn't use substitution or elimination, but they get a bit tricky because of the bookkeeping that you have to do for all the different variables that you're canceling, and so forth. So in order to solve this with Gauss-Jordan, what we're going to do is first change this into what's called an augmented matrix. And this augmented matrix will have the same number of rows as equations and the same number of columns as variables, plus an extra column for the constants. So everything in the first column will be multiplied by x, everything in the second column will be the coefficient on y, and everything in the third will be the coefficient on z. And then we'll have this bar, which represents the equal sign, and our constants. So our first row in this matrix would be the coefficients 4, 6, 2, and 0. Then the second would be 3, -5, 2, and -2. Then 2, 3, 1, and finally 6. So that makes up the coefficients of our augmented matrix. Now, the Gauss-Jordan method is actually rather involved itself and very prone to arithmetic error, so we're going to use the calculator to help us out here. And in the calculator, if you hit second and matrix, which is the x to the -1 key, and slide over to the edit menu. That's where you can enter coefficients of a matrix. So go into the edit menu. I have 3 rows and 4 columns, so a 3 by 4 matrix is what I want. If you have something different, change those values so you have enough place to input everything. And then start entering the coefficients of your system. And do be careful to make sure you type those in correctly, because the only way to really get a wrong answer in this process is to enter the wrong matrix in the first place. So it's also a good idea just to double check and make sure you have the right ones. Once you're done, quit out of the matrix editor, but then enter the matrix menu again, so second and x to the -1. But this time we want to do some math, and we're going to come down to the function RREF, which stands for row reduced echelon form. And that is different from REF, so be careful there. Once you find it, press enter, and then tell it the matrix that you want to do this for. So back into the matrix menu again, matrix A is what we entered, and just close that parentheses and press enter. Now, if you'll notice, we've got some crazy decimals here, but don't worry about that sort of thing. If you have that, one thing that might be able to help is to use the math menu and then the option convert to fraction. And it will take those decimals and do its best to convert those decimals to fractions so they don't seem so random anymore. Okay, so this is our solution. So let's copy this back over here. So we have 1, 0, 11/19, 0. 0, 1, -1/19, 0. 0, 0, 0, 1. Okay, so as a system of equations, what this would look like is, remember, everything in this first column is multiplied by x. So this would be x plus 11/19 z equals 0, then y minus 1/19 z equals 0, and 0 equals 1. So this part right here, that is a contradiction. And whenever you notice that this contradiction exists, what that tells you is that there's just no solution to this system. So you don't have to parameterize or do anything else. Once you see that contradiction, you can state that the system has no solution.